day, everyone. I hope that you are all doing great. Let me introduce to you to our discussion today, which is all about the nano world. Here are our lesson objectives. By the way, I'm together with my co-reporters that you will be able to meet later on. And of course, I'm Divine Grace of Being and I am the first reporter of the group. As we go through with our discussion, I want everybody to pay attention and keep quiet. So here we go. I've prepared here a video introduction for you to know what is Nano World all about. Nano World, which come from the combination of two words, which is nano and world. The term nano means is a unit prefix meaning 1 billion, used primarily with the metric system. In terms of sizes, it is incredibly small and impossible to see by a human naked eye. The second word is which means the whole physical universe. Now that we have a little background what does nano world means, why don't we dive right into it, shall we? A nanometer is a unit of measurement for length, just as you have it in centimeters. First, to put things into perspective, this is how small a nanometer is. It is equivalent to 0.000000001 meters. That is 1,000 times smaller than a microbe. With the size of a micrometer, a microbe is 10,000 times smaller than a centimeter. Nanoscale is mind-shroudingly small. In fact, it is so small that the region of laws of physics that we believe is absolute started to collapse at that scale that is collective brilliance pieces, and scientists started forming quantum mechanics. Now that you've already watched the video, nano refers to something that is very, very small, right? Now, let's talk about nanotechnology. This is basically about working with incredibly tiny particles called nanoparticles at the nanoscale level. This involves manipulating and studying materials at the molecular or atomic level, which can lead to new materials, devices, and applications with unique properties and functions. Keep in mind, guys, that because of physicist Richard Feynman, scientists can direct and control individual atoms and molecules in stock. There is plenty of room at the bottom. The concepts of nanotechnology and nanoscience started on December 29, 1959, and the term nanotechnology was coined by Professor Norio Taniguchi. Imagine, guys, how small the nanoscale is. It is incredibly tiny. It's about a billionth of a meter. So things at the nanoscale are so small that you need special tools like powerful microscopes to see them. For the discussion on how to view nanomaterials, let's have our next reporter, Mr. Alfred. Are you there?
Yes, Vine, I'm here. So, hello everyone, I am Alfred, and at this juncture, let's talk about how to view nanomaterials. So first, we have electron microscope. A microscope that uses a beam of accelerated electrons as a source of illumination. In 1930, German engineers Ernst Röska and Max Knoll built the first electron microscope. So ang kaning electron microscope, usa ni siya ka-instrument which is a beam of electrons mo na siya ang gigamit para mag-produce og enlarged image of a very small object. So, kaning electron microscope, gigamit siya para mag-investigate o ultrastructure or kaning mga inorganic specimens including microorganism, cells, large molecules, biopsy samples, metals, and crystals. So, sa picture, makita jud na to ang beam of electrons, no? So, which is naa siya sa top of the microscope by an electron gun. So, nadiha. Then, the electron beam follows a vertical path through the microscope, so which is held within a vacuum. So, ang kaning beam mo travel siya through electromagnetic fields and lenses. So, mao na mafokusan ang beam down towards sa sample or kaning object na mao i-focusan. So, as you can see the picture na mao jud na ang forma sa electron microscope. So next, we have atomic force microscope. So, it was first developed by Georg Binning, Calvin Quick, and Christoph Gerber in 1986. It makes use of mechanical probe that gathers information from the surface of a material. So, ang kaning atomic force microscope is primarily gigamit siya for imaging and measuring the surface of materials at the nanoscale level. So, it uses a tiny probe that typically with a sharp tip that scans the surface of the sample. So, the interaction between the tip and the surface provide information about the surface, topography, texture, and other properties. So, atomic force microscope is mo-obtain po ni siya og high-resolution surface images of materials sa nanoscale level. So, it can reveal details such as surface roughness, texture, and features of atomic resolution. And also, ginagamit po ni siya sa biology and biophysics to study biological samples such as cells, proteins, and DNA. So it allows researchers to examine the surface morphology and mechanical properties of biological specimen with high precisions. So, mo na ang atomic force microscope. So, this is the last part of my report, which is the scanning tunneling microscope. So, this special type of microscope enables scientists to view and manipulate particles, atoms, and small molecules. In 1986, Jörn Binnig and Heinrich Rohr won the Nobel Prize because of this invention. So, ang kaning scanning tunneling microscope is a microscope used for imaging and manipulation of atoms and surface of materials. So, unlike sa atong atomic force microscope, gigamit siya for imaging and measuring of the surface of the materials at the nanoscale levels, while sa kani, gigamit siya for imaging and manipulation of atoms. So, nag-focus siya sa mga small particles or kaning mga atoms. And it operates based on the principles of quantum mechanics, where a sharp conducting probe scans the surface of the sample. So, the interaction between the tunneling current and the material surface allows for the generation of a three-dimensional image of the atomic scale, providing detailed information about the atomic structure, surface topography, and electronic properties of material. So, that will be all my part, and let me call on the next reporter, Miss Queenie. You may now take over.